Hi everybody, welcome back to the Feynman Technique. So today we're going to be deriving Legendre's duplication formula. I think that's how you pronounce it, but it's that guy right there. I think he's a French guy, French mathematician. I believe you pronounce his name Legendre. Okay, but anyway, it the Legendre duplication formula um, basically multiplies gamma functions that are shifted by a factor of 1/2 together. So basically like this, gamma z times gamma of z plus 1/2. So what's that equal to? All right, we're going to be using these. I'm going to be using these things. This is kind of our toolbox. We've already derived and talked about these things on this channel before. This is just the beta gamma relationship right here. And this down here is just the trigonometric representation of the beta function. It's just the standard beta function with a substitution applied to it. And then we're also going to be utilizing gamma of 1/2 equaling square root of pi. And we've shown that. We've shown all this and talked about all this on the channel already. So go back through the most recent videos of mine to see, to learn about these things. Okay. So the first thing we're going to do is let's make a symmetric beta integral right here. In other words, we're going to evaluate beta of z comma z. So our original beta definition was this, the trigonometric representation of the beta function right here. And then we just take beta of z comma z, and this is what we have. All right. And then we're going to group the trig terms all into one term raised to a single exponent. All right. And then let's just rearrange that. Basically, all we're doing upstairs is multiplying by 2 and dividing by 2 to get our double angle formula up here. And then next we factor out all the multiples of 2 outside of our integrals. So now we have beta z comma z is just equal to this integral right here. And then we do a little bit more simplification. Let's see, what did this step accomplish? Nothing. It's just we're calling this beta of z comma z is equal to this. Basically, we just consolidated everything into a single exponent on our factors of 2 there. All right, and now we're going to make the substitution u is equal to 2x. So dx is du over 2. And we put that into our beta zz integral. And we have this. All right. Well, let's see. We have sine over a symmetric integral. Maybe we can use that. Nope, it looks like first what we're going to do is we're going to bring out this factor of 2 and apply it to our exponent here. All right. Aha. Now we're going to do this. You'll notice this integral right here, sine, is going to be symmetric about the line pi, or x is equal to pi over 2. So we can say that that integral is actually twice the integral going from 0 to pi over 2. All right, so now our beta zz integral is just, well, it was this. Now look what we're doing. We convert this to twice the integral going from 0 to pi over 2, which it is. And then we do something clever to make it match our beta zz integral. We're going to add a cosine term here. If we add a cosine to the 0 term here, that's just 1. So that doesn't change anything. And we're just trying to get this beta integral back to its standard form. All right. And then we'll just replace our 0 with a 2 times 1/2 minus 1. You see what we're doing here? We're trying to get it into this form, this 2z minus 1 form. And this would work. This would be the z is equal to 1/2. Okay. So now we have beta of zz is just equal to 2, this factor of 2 right here that we had outside of our integral times beta of z comma 1/2. You'll notice that this integral right here is just beta of z comma 1/2. All right, so beta zz is equal to this multiple of 2 times beta of z comma 1/2. All right, and now we're going to replace our beta zz with its equivalent gamma representation using our beta gamma relationship right there. So we just replaced gamma z over gamma 2z and set it equal to our right-hand side right here. Okay, now what are we going to do? Well, now let's use beta z comma 1/2 and plug it into this. Plug it into our beta gamma relationship. And if we do that, we see we end up getting this. And now you'll see we have some cancellations that we can do. We have a factor of gamma z on both sides that can come out. All right. So let's see what happens next. Yep, this gamma z is going to cancel on both sides. And then we just do some rearranging, and we'll also use the fact that gamma of 1/2 is square root of pi. So from here, these cancel. The gamma 1/2 becomes square root of pi. We've already shown that. And then we just do some rearranging to get this. All right. So next, we just do a little bit more rearranging. You see, we have all the parts here. We just do a little bit more rearranging. And we have the Legendre duplication formula. All right, guys, I hope you enjoyed that, and we will see you next time.